So starting off, 2.6. 2.6 is going to be over what we call complex numbers. Okay? We start off just kind of categorizing these numbers. So we've seen this chart before. We've got rational numbers, integers, whole numbers, and then natural numbers. And then over in that second column, we have our irrational numbers that we've talked about. Okay? And now we're going to talk about what we call imaginary numbers. Okay, imaginary numbers are not real. Just like imaginary friends, unfortunately they're not real friends, are they? Sometimes. Well, not today they're not, okay? So that is why they're in their own category, okay? The reason we have imaginary numbers is to deal with even roots of negative numbers. So we've actually already introduced I, okay? Just because I knew that this is a big thing and I wanted you to see it a little bit early before we just dove right into it, okay? But that is what an imaginary number is. It's just that letter I is how we abbreviate that. So what is the square root of -4? Well, we know that looks like this in radical form, square root of -4. But then we know this is the same thing as square root of -1 times the square root of 4, correct? Yes. And just like we said in that other class, anybody remember what is the square root of -1? I. Yep, letter I. Just means imaginary. So I can break this down into just I times the square root of 4. And what does the square root of 4 break down to? 2 and 2, which is just a group of 2. So I times 2 or 2I would just be the answer to this. Okay? So since we can't take the square root of -4, we use I to take the place of the negative, but then we solved it like normal. So that's the important part to remember on these, okay? The solving part isn't changing. There's no new way to do this, okay? The only thing that's changing is the fact that we're introducing that imaginary value, okay? So we've talked about what I is. We know that I is just the square root of -1. And I'm just going to put that equals I, because obviously it does. I is the square root of -1. The square root of -1 is I. Okay? Then we have I squared. Well, if I know that I is the square root of -1, and I know I squared is just I times I, wouldn't it just be square root of -1 times square root of -1? And what happens when I am multiplying by a radical that has the same radicand? Yeah, it cancels out the sign. Okay, so when it does that, my answer is just going to be -1. So what I'm saying here is that I is just going to be I squared is going to be -1. Circle, star, box these in, do whatever you need to do. These are the ones that are going to be on your test. Okay? These are the ones that are super important. They are going to be on your test. I'm going to introduce the rest of these to you, okay? But don't freak out if it's a little bit confusing for you, because they're not going to be on the test. But I definitely need you to know what I and what I squared are. And we'll be dealing with those today too, okay? So if I have I to the third, I know that this is just the same thing as I squared times I, right? Or I could even break it down. It would be square root of -1 times square root of -1 times square root of -1. Well, these first two is just I squared, which we said was just -1. Square root of -1 is just I. So -1 times I is just -I. With me on that? What about I to the fourth? How could I break that down? Well, I is square root of negative 1, right? So I just have that being multiplied 4 times. Yep, it's going to equal positive 1, because it's going to be negative 1 times negative 1, which is just going to be 1. Okay? These two are not super important, okay? Because as long as you know the first two, you can get yourself to those two, okay? But I definitely need you to know the first two. And I definitely would write those other two down. What we're then going to find out is that these 4 values just make a pattern, okay? When I have I to the 5th, well, I know that that's the same thing as I to the 4th times I, right? What was I to the 4th? It was just 1, and what's I? Square root of negative 1, or we can just leave it as I. Okay? When we get to 6, I to the 6th is the same thing as I to the 4th, which we said was 1, times I squared, which we said was negative 1. So 1 times negative 1 is just going to be negative 1. So it's just going to keep going in that same pattern. I, negative 1, negative I, positive 1. So if I had I to the 57, I could just break that down, right? Could see how many times 4 goes into that, see what that remainder is, and then pick remainder of 1, remainder of 2, remainder of 3, goes in evenly. You with me? Okay, that's not super important for this test. So that's as far as I'm going to go for this, okay? If any of you guys are college algebra bound, this is something that you will do then, and you'll hit on then, okay? But I just kind of wanted to introduce you to it. But as for today, really the only thing that we've got to know is we've got to know those first two. So as long as you're good on that, then I'm not worried about going any further with this. Is that cool with you guys? So we're going to go ahead and dive into this next part. So it says, given the following radicals, just simplify. So this is going to be similar to what we've already done. We've actually already done this before. So if I've got square root of negative 12, that's just going to be the same thing as square root of negative 1 times square root of 12, right? Square root of negative 1 is I, and then I can break 12 down into 6 and 2 or 3 and 4, whichever one. I end up with I times 2 square root of 3. You with me on that? So my answer, I'm actually going to write the coefficient and write the I at the end. So 2 square roots of 3I. Okay. Because we've already done this, and just to save a little bit of time, we're going to skip B and C, but I want you guys to do D and E. So go ahead and do those. All right, square root of negative 72. What'd you get? What did it break down to? What? Still can't hear you. 6 square root of 2. Okay. What did 72 break down to?
9 and 8.
9 and 8. So 9 breaks down to 3 and 3, 2 and 4, 2 and 2. Okay. We've got a group of 3, a group of 2. 3 times 2 is 6 with square root of 2 left over. And then what is the one thing that's missing? The I, right? Good. And then square root of negative 18. 9 and 2. 3 and 3. Got to make sure we pull the I out too. So 3 square root of 2I. With me on that? Okay, great job. Any questions, or are we good to keep going? Good? All right. What is a complex number? So a complex number is when you put a real number and an imaginary number together? Who would do such a thing? Mathematicians, I guess. You could be one if you wanted to. Be a good path for you. Okay, example of a complex number would just be 4 plus 5i, or 7 minus 2i. There's a billion of them, okay? Complex number is just adding or subtracting a real number and an imaginary number, okay? So, given example 1, it says to write that in complex number form, okay? Well, it looks like I've got square root of negative 16. I know that that's an even root with a negative under it, so I know that's going to be imaginary, right? 16 can break down to 4 and 4, which breaks down to 2 and 2, where you just could know that the square root of 16 is 4, right? 2 times 2 is 4. So this is just going to be I times 4, or 4i. So 4i plus 4. That is all. So I just added that 4 back on at the end. That is a complex number. Oops. Okay, here we go. When adding or subtracting complex numbers, you can only combine like terms as normal. So do not try to add things that are not like terms. If a real number is being added to a complex number, those are not like terms. 4 and 4i cannot add to be 8i, okay? Because that first 4 did not have an I on it. Just like 4x plus 4 is not 8x, okay? These work the exact same. So looking at letter A, this is super similar to what we did in our warm-up, right? What operation we got going on? Addition, okay? So even though there's parentheses, we still have an addition sign between them, which just means we're adding, right? So I can technically drop those parentheses if I want to. 10 plus 5i plus 14 minus 7i. In the warm-up, our next step was to combine like terms. We're going to do the same thing here. What are my like terms? 10 plus 14 is, and 5i minus 7i, what is that, Timmy? Perfect. You're so smart.
I am a mathematician.
You are a mathematician. We all are. Good point. Okay. The next one, letter B. What are we doing here? Are we dropping them? Are you sure? There's a minus sign. But what do we have when we have a minus sign in front of that second set of parentheses?
Nothing.
Got to distribute it out, right? We are subtracting, but we're subtracting by that whole thing in parentheses, both terms inside those parentheses. So I've got to distribute out that negative 1. So 8 plus 3i, I can drop those parentheses. But now I've got negative 1 times 2, negative 2, and negative 1 times 4i, negative 4i. Okay, so go ahead and simplify that, get your complex number, and then do letter C. Okay, what did this simplify to? Letter B. So she said 6 minus I. Perfect. 6 minus I. Question. Yep.
I wrote like the negative I plus 6.
Yep, and that is the exact same thing. Great question. So she wrote negative I plus 6. That is the same answer. I wouldn't count that wrong, okay? But technically, they want us to write the i's at the end, okay? Just like with whenever we had like x to the third minus x squared, we wrote those exponents in descending order, okay? So technically, an imaginary number is descending after a constant. But good question. If you put negative I plus 6, I wouldn't count it wrong, though. Okay? Letter C. What we got going here?
Distribute the negative.
Good. Distribute the negative. So this just becomes
7 minus negative 2 minus 8i.
7 minus 2 minus 8i, you mean?
That's what I said.
You said minus negative 2.
No, I didn't. Yes, you did. Come on, man.
It's in the video. You can go back and watch it.
Oh,
Because I'm recording right now. Yeah, because I forgot to record yesterday. Dude, what the heck? It's fine. 7 minus 2. 5 minus 8i. Good. You're a mathematician.
I got it.
All right. Multiplying complex numbers. When multiplying complex numbers, we can combine exponents like normal. So as long as our base is the same, we can still combine the exponents. So if we look here, we got 5i in parentheses next to negative 4i. What are we doing? Multiplying, because there's no addition or subtraction sign. They're just written next to each other. So same thing is going to work here as what I do with variables. Multiply the coefficients, 5 times negative 4. And then multiply my my bases and my exponents. So as long as I have the same base, I can add the exponents. My base is I, add the exponents to give me I squared. So negative 20i squared. But hold on. We already talked about what is I squared. Go back in your notes. It's negative 1. I squared is negative 1. So are you saying that this is the same thing as negative 20 times negative 1? Which is 20. So that is your answer. So don't leave any I squareds in your answer. It's okay to have an I in your answer, but if you've got an I squared, you need to go ahead and put a negative 1 in there in its place. Okay?
Well, what if it's an odd one?
What if it's what?
An odd one.
What do you mean?
If it's like negative 20i to the 5th.
So that's kind of what we talked about in our notes, okay? So you would just, so if you had I to the 5th, wouldn't that be the same thing as I to the 4th times I? And we know that I to the 4th is just 1. We know I is I, so it would just be I. Oh, okay.
So it all just goes back to I?
It all just goes back to I. Yep. Well, not all of them. Well, it's going to go back to whatever's left. But really, for the test, you just need to know I and I squared. So don't overthink that for now, Timmy. But that was a good question. Okay. Next up, letter B. What do you think we're doing here? Foiling. Good. So we'll start with first term. 6 times 4.
24.
6 times negative 3i.
Negative 18.
Good. Negative 5i times 4.
Negative 29.
Negative 5i times negative 3i.
Negative 15i squared.
Plus 15i squared. Yep, because the two negatives make a positive. Okay. Next thing I want to do is get rid of my I squareds, because we know we can't have those. What are I squareds? Negative 1. So this is the same thing as 24 minus 18i minus 20i plus 15 times negative 1. What is 15 times negative 1? Just a negative 15. So that's what I'm going to write there. Negative 15. Now I can combine like terms. So my first set of like terms. What'd you say? Okay, what is negative 18 minus 20i?
Positive 2i.
Mm,
Oh, wait. Just kidding.
negative 38i. Good. And then what's 24 minus 15? 9. Okay. So I'm going to have 9 minus 38i. If you put negative 38i plus 9, you're fine. Okay? This is just the more proper way. Questions on that?
You know my brain's running.
Got your brain running. Good deal. Okay. Go ahead and do C and try D. Letter C. What'd you do first? Yep, FOIL. So first is,
4 times 4.
which is
6.
4 times 3i.
12i.
Negative 9i times 4.
Negative 36i.
And negative 9i times positive 3i.
Negative 27i squared.
Perfect. Raise your hand if you got that far. Good, 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 good. I think that was everybody. All right. Next up, I need to
Get rid of the square root of squared.
get rid of I squared, and it is just negative 1. So negative 27 times negative 1 is just 27. Now I can just combine my like terms, right? What are they?
43 minus 24i.
43 minus 24i. Raise your hand if you agree. Good, 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 good. All right, next one. This was very, very similar to the one we did on the warm-up, okay? What are we doing? Multiplying. So we'll just go from left to right. What's 3i times 2i? 6i squared times 7 minus 5i. Okay? What you might have done is you might have distributed that first, which is fine, but you're going to end up with an I cubed. Okay? Did anybody do that? What's something I could do before I distribute this out? Yep.
What I did is I did the 6i squared times negative 1 and got negative 6, and I was going to distribute that.
Perfection. Yes, that is what I want you to do. If you see an I squared, if you catch that from beginning, go ahead and get rid of it, okay? Because it's not going to help you. Make it simpler. It's just negative 1 times 6, so that's just negative 6. And now this is a pretty easy problem. Negative 6 times 7, and negative 6 times negative 5i. Positive 30i. And that's it. That's my answer, because I cannot combine those. Okay? Questions on that? So get used to killing those I squareds as soon as you see them. Okay? It's going to help you. Letter E. We're not going to do this one just to save some time, but how would I set this up? What does that exponent tell me to do?
Times it by itself.
Yep, times it by itself. So it would just look like 3 plus 2i times 3 plus 2i. Good. Good, good, good. Okay. Now we've got our radicals here. So we're just going to be putting them into imaginary numbers, right? And seeing what we get. So let's break these down. Square root of negative 49 times square root of negative 4. We'll break down 49 into 7 and 7. We'll make sure we pull the I out too. So that just becomes I times 7, right? Times I times 2. So 7i times 2i, or 7 times 2 is 14. I times I is I squared. And what will this become?
Negative 14.
Negative 14. Because I squared is negative 1. Good. Questions on that? Okay, go ahead and try letter B. Okay, B, what did it break down to? You said 6i times 9i equals 54i squared, which is negative 54. Great. Raise your hand if you got that one. Good. If you didn't, make sure you know 36 breaks down to I. Square root of negative 36 breaks down to I, and then 6 times 6 gives you 6i. 81 breaks down to 9 times 9. Okay, let's keep going. If I see one like this, don't say, oh my gosh, okay? It's not scary. Don't multiply it like it is, okay? Don't try to even mess with that, okay? Simplify these radicals, put them into imaginary numbers. because then it's going to be a whole lot easier, okay? So how I would do that is I just take the radical, so square root of negative 12, and put that into an imaginary number. 12 breaks down to 4 and 3, and 4 breaks down to 2 and 2. And we obviously have an I outside as well, right? So this is just 3 minus 2 square root of 3i. And then we've got the square root of negative 27. That's going to have an I in it. And then 27 breaks down to 9 and 3. So I've got one group of 3 with a 3 left over and an I. That looks a little better, right? No?
It's still there.
It's still there. Well, it wasn't going to disappear. We got some disappearing coming up, though. It'll make you happy. Some shortcuts in the next couple. So on this one, we got 3 times 5, 15. 3 times 3 square root of 3i. Okay, these work just like with our variables, just like with our radicals, as what we've been doing. You only multiply outsides and insides. Okay, so outside to outside, inside to inside. 3 times 3 is 9. And then just keep your square root of 3, keep your I. Same thing with negative 2 square root of 3i times 5. Multiply my outsides. Negative 2 times 5 is, keep my square root of 3, keep my I. Then, the last little part. This is the one that yesterday we were having a hard time visualizing. So I'm just going to underline my last little multiplication problem, and I'm going to write it out here. Okay? Yep, negative 6 times 3 times I squared, okay? So how I did that? First, multiply my outsides. I get negative 6. Then multiply my radicals. Square root of 3 times square root of 3. The signs just cancel out to give me 3. Then I've got I times I, which is I squared. What is I squared? Negative 1. So this term is just 6 times 3 times negative 1, which is close. 6 times 3 times negative 1, positive 18. Yep. Okay, that's a tougher little piece right there. So if you've got to pull those out for the first few, just so you can visualize that, do it, okay? I'd rather you do that than get it wrong. So now we just can combine like terms. 15 plus 18 is, plug that in.
30.
33. And then 9 square root of 3i minus 10 square root of 3i. Yep. Negative 1 square root of 3i. Perfection. So that would be my answer on that one. Questions on that? Okay. Ready to move on. Last one here. Do we feel good about the last problem? Do we want to do this one? We do want to do this one? Yeah? Okay, let's do it. Go ahead and try it. Give it a shot. So we know that we're foiling, okay? But we know that we've got to simplify these values first. So the square root of negative 12, what'd you get for that? Yep, so 2 square root of 3i, and there's a negative in front of it because of that negative sign that's in front of it. Okay, what about the square root of negative 48? 4 square root of 3i, so 3 minus the 4 square root of 3i. Everybody get that? How to do that one? Okay. So now we just FOIL. 4 times 3 is 12. 4 times negative 4 square root of 3i.
Negative 16 3i. What the square root of?
Uh-huh. Then we got negative 2 square root of 3i times 3. Perfect. And then the last piece, negative 2 square root of 3i times negative 4 square root of 3i. Positive 8 times 3 times negative 1. What is positive 8 times 3 times negative 1? Negative 24. So this piece just becomes negative 24. Now I'm going to combine my like terms. So negative 12 minus 24. Or sorry, positive 12 minus 24 is negative 12. I was thinking ahead. Okay. And then negative 16 square root of 3i minus 6 square root of 3i. Good. Questions on that one? Anybody get that one perfectly? Okay. Well, let's keep going. So reminder, a conjugate is just the opposite form of a value. Okay, so a conjugate is just changing the sign in the middle. So 3 minus 2i would just be 3 plus 2i for the conjugate. We all remember those?
Yeah.
Same thing as when we dealt with radicals, okay? Just changing the sign in between. The reason that we multiply by a conjugate is just to get rid of the radical if it's in the denominator, or just to kill that radical. We just want to get rid of it. Okay, we cannot have a radical in the denominator. So we're going to multiply the two complex conjugates and see the result, okay? So just showing you how this works. Foiling, 3 times 3. 9, 3 times 2i. Negative 2 times 3, or sorry, negative 2i times 3. And negative 2i times 2i. Negative 4i squared. Okay, do we see how the middle, 6i minus 6i, what happens? Cancels out. So we're just left with 9 minus 4i squared. We know that I squared is just negative 1. Negative 4 times negative 1 is 4. So you're saying I just have 9 plus 4? Oh yeah, 13. Good. That is my answer. Okay, so the whole point of a complex conjugate is just to cancel out the middle. Okay, it's going to happen on every single one of them. So I'm going to go ahead and skip B just because we're going to do some more on the next page. So on C, what would be the conjugate for this?
5 minus 2i.
Yes, and when I have two variables being added or subtracted in the numerator or the denominator, get used to writing those parentheses, okay? So we said 5 minus 2i is what I'm multiplying by on both top and bottom. We'll go ahead and do the bottom because we know what's going to happen. We know the middle is going to cancel out, so I'm just going to do 5 times 5 is, and then 2i times negative 2i. Negative 4i squared. That's it on bottom. On top, what am I doing? Distributing. Negative 3 times 5 and negative 3 times negative 2i. Positive 6i. What's your signs? Okay. On bottom, what's that negative 4i squared become? Yep, so this is just 25 plus 4, which is 29. And on top, it's not going to do anything because those are not like terms. So that's just my answer. Okay? Questions on that?
Got anything harder?
Anything harder? It's too easy for you?
Yeah.
Okay, go ahead and do D. And then just looking at letter E, what's different about letter E? Is that one going to have a conjugate?
Yeah. No.
No, why?
It's on
It's not on
the top.
the denominator. The denominator is just 4i. So that one's going to work just like we had our last radicals. Like if I had 5 plus 2 square root of 2 over the square root of 4, I would just multiply by square root of 4, right? So same thing's going to happen with these. I'm just going to multiply by 4i over 4i. So go ahead and try D and E. I'll give you about 2 minutes. Okay, help me out on D.
Okay.
Okay.
You got a conjugate.
Conjugate, yep.
The bottom. So you got multiply by 4 sides.
So what is the conjugate?
1 plus 4.
Good. 1 plus 4i. 1 plus 4i. Just change the sign, right? Okay. So we'll start with the top now. What does that become? 4 plus 16i. And on bottom? 1 minus 16i squared. Good. Raise your hand if you got that far. Good deal. Okay, so that is definitely going to be key for learning this unit. Okay, you've got to be able to at least make it that far to do well on your test. Okay? On the bottom, this is going to simplify. 1 minus 16i squared is just going to be a plus 16. Good. So 1 plus 16 is 17. And then the top stays the same, right? Can this simplify? Not this time. 4, 16, and 17. Do those have anything in common that I could pull out? No. So that's it. Okay. Now we've got E. We're almost done, guys. 2 more problems. I already gave you what to multiply by. So on the top, 20i plus 8i squared. And on the bottom, 16i squared. On the top, what does 8i squared become? Negative 8. So this is just 20i minus 8, or negative 8 plus 20i. And on the bottom, negative 16. Okay? My key thing here, I want you to be able to get to this point. Okay? That is what I'm going to be grading you on. That's what on the test I need to see, is that you can get that far. There is one more thing, though, that I can do. I can simplify this. What is a number that all of those have in common? 4. Okay, so negative 8 divided by 4 is negative 2. 20 divided by 4, 5i. And then negative 16 divided by 4. Negative 4. Yep. So that would be the simplified version. I even could have taken out a negative 4, and that would have just made this a positive 2, a positive 4, and a negative 5. Okay? Which would have also worked. But either way, you did it. Okay? Again, I just really need you to be able to get to this point. But if you get to this point, that's extra in my book. Okay? We should know how to simplify by now. But that was an Algebra 1 thing. So we do need to at least attempt to do that. Okay, letter F. Let's just go ahead and do this one together so we can be done. We got 4 minutes left till lunch, so let's get this one over with. What should I multiply by? Okay, on top it becomes
20
10i plus 20i squared. Good. And then on bottom? 25i squared. Okay. The top, what does that simplify to? Negative 20 plus 10i. And on bottom? Negative 25. Will this simplify? Yes. If you see that, awesome. What can I pull out? 5 or even a negative 5. So negative 20 divided by negative 5. 4. 10 divided by negative 5. Negative 2i. And then negative 25 divided by negative 5. 5. Okay. Questions on those? No? We feeling like mathematicians today. What's your question? What'd you say? Okay. All right.